Hi, this is Tim Alosi at New England Controls, and today we're here to talk a little bit about abnormal situation management. Well, unfortunately, abnormal situations are kind of normal in all of our facilities. Oftentimes, we associate them with alarms, but quite frequently, the abnormal situations are actually caused by something else that resulted in an alarm. It could be a measurement that was bad, an instrument that was bad, a device like a valve that's in the wrong position, and these often result in alarms. So when we talk about abnormal situation management, there's three components that we like to talk about. The first is applying good design practices to reduce the likelihood of abnormal situations. The second is to make sure that we are presenting the operator with the information in a clear and effective way so that they can recognize an abnormal situation when it happens. And the third concept is to help the operator respond effectively by presenting them with the right information for the situation as it presents. Today we're going to talk about design, and specifically about simplifying how the automation system is organized in order to help the operator operate their plant and reduce the likelihood of making mistakes. And we do this with something we call an equipment-oriented approach using equipment modules. Now, as you can see from our demo here, we have a vessel, and that vessel has some temperature control. And the temperature control, as you would expect, is actually a little complicated. There's a couple of block valves here, there's a couple of control valves, there's a couple of control loops, and some measurements coming from the vessel, along with a recirculation pump. Now, if the operator has to remember all the right positions to put these devices in order to effectively control the temperature, the likelihood of him making a mistake is a little high. So, what we've done with our equipment-oriented approach is organize all these devices that perform a common function, temperature control, into an equipment module. Let's take a look at how that works. So the operator, rather than controlling the individual devices, can control the whole temperature module, equipment module, from a single faceplate. So the first thing he would do would be acquire the temperature equipment module, and what we'll see is a series of locks show up on the screen. These locks indicate that these devices are owned. They may be owned by a batch. In this case, they're owned by the operator and the equipment module. If the lock isn't present, the operator can still control a valve just like they normally would. Let's go back to our temperature module. So once the operator has acquired it, they can select a mode, such as jacket mode or internal mode, and then send the command to run. Now what we're going to see here, we see in our message area that the equipment module is initializing, any previous holds are being cleared, they're enabling any failure monitoring, and they're setting up the module for temperature control using the jacket. We just see the pump start. In a second we'll see our block valve open, our control valve open, and I had previously requested that the jacket get ramped down to 50 degrees, and we're seeing that that ramp now is active. So as you can see, this provides an optimized and simplified interface to our equipment, helping the operator more effectively control our plant and reducing the likelihood of abnormal situations. I hope that this has been a helpful screencast, and I hope to see you all at the ISP Tabletop Show in October of 2011.